Hello everyone, today I want to show you this. It's called a slide rule, and I'm going to show you how to use this to perform calculations, so multiplication, division, squaring a number and so on. It's what they used to use before pocket calculators, so people like mathematicians, engineers, physicists, you know, cool people. I'm going to show you how to use this, and then finally I'll show you why this worked. They were big in the 50s, but then again, so were rickets. So when you first see one of these, they look a bit baffling. They look a little bit like a ruler, except this bit here in the middle slides across. So hey, it's not just a clever name. If you look closer, you'll notice that the scales aren't uniform. So here, there's a large gap between the numbers 1 and 2, but there's only a small gap between the numbers 8 and 9. But how do I use this to multiply? So well, luckily we can ignore most of the scales here on the slide rule. The only ones we need to use are the scale here on the sliding part and the scale underneath it. So let's say I want to double a number. So what I'm going to do is I'm going to move the scale across so that the number 1 on the left hand side lines up with the number 2 underneath it. So I just slide that across, so now 1 becomes 2, and I've doubled it. But if I do that, the whole scale gets doubled. 2 becomes a 4, 3.2 becomes 6.4. So that's how I would multiply by 2. You slide it across so that it lines up with the number 2, and then the whole thing gets doubled. But the scales only go up to 10, so how do you do something bigger? What if I wanted to calculate 250 times 3? How would I use the slide rule to do that? You have to make all the numbers less than 10, and then you estimate the magnitude of the final answer at the end. So if I want to calculate 250 times 3, I can use the slide rule to work out 2.5 times 3. I can do that. I just slide the scale along so that the number 1 lines up with the 3. This triples the whole scale, and 2.5 times 3 is 7.5. If I want to know 250 times 3, well, that's just 100 times bigger. So the answer is 750. But what if I wanted to know 7 times 3? If you can see, the 7, it falls off the end of the scale. So how do I calculate 7 times 3? You use the right hand side of the sliding scale instead of the left hand side. So you move the right hand side across so that it lines up with the 3, and now 7 becomes 2.1. But the answer obviously isn't 2.1, the answer is 21. So you have to use your common sense. What if I wanted to do something a bit more complicated? What if I wanted to calculate 455 times 615? Well, I can use the slide rule to calculate 4.55 times 6.15, and I get the answer 2.8. But that's not the final answer. I need to calculate the final magnitude of that, which is... Now division is just the reverse of multiplication. So if I line up 1 above 2, then 2 times 4 becomes 8. And if I want to know 8 divided by 4, that's 2. It's just the reverse. Let's have a look at some of the other scales. Right here in the centre, this is the reciprocal. So the reciprocal of 4 is 2.5. You just read that straight off. This scale here near the top is the square of the number. So 4 squared is 16. And then right here at the top is the cube of the number. So 4 cubed is 64. You can just read those straight off. Here at the bottom is the log of the number. So what is a log? The log is the power of 10 that you need to make that number. So the log of 100 is 2, because you need 2 powers of 10. 10 times 10 is 100. The log of 1,000 is 3. You need 3 powers of 10. 10 times 10 times 10 is 1,000. But you can do numbers in between as well. The log of 525 is 2.72. In fact, we're going to use logs to explain the secret of the slide rule. So how does the slide rule work? Well, logs have a special property. The log of x plus the log of y is equal to the log of x times y. So if I wanted to work out x times y, one way I can do it is I can add the logs together, log x plus log y, I get a result, I then reverse the log process and I get x times y. So you add the logs together and then reverse the log process. So for example, let's say I want to do 21 times 25. Well, I can add the logs together and I get 2.72. I then reverse the log process, and the reverse of the log process, that's 10 to the power 2.72, and I get the answer, 525. So imagine we've got two log scales, and notice the log scales are not uniform. There's a large gap between log 1 and log 2, but only a small gap between log 8 and log 9. Now, let's say I want to do something simple. Let's say I want to do 4 times 2. So I'm going to add the logs together, log 4 plus log 2. If I want to add log 2, what I can do is to slide the top scale across to the right, log 2 across, and that will add log 2 to everything. So log 4 plus log 2 is log 8. I then reverse the log process to get the final answer, 8. Now, the scales on the slide rule are designed to do that last step for you. So you don't have to do this reversing part of the process. You can just read the answer straight off. And that's how and why a slide rule works. So, well, if you have been, thanks for watching.